Welcome everyone to today's lecture on HDFS fundamentals. In this session, we will explore the Hadoop Distributed File System, which is one of the core components of the Hadoop ecosystem. Before we dive into the technical details, let me set the context. Imagine that you are working with massive data sets, perhaps terabytes or even petabytes of data that cannot fit on a single machine. Traditional file systems would fail in this scenario. This is where HDFS comes into play. HDFS was designed specifically to store and manage enormous amounts of data across multiple machines in a reliable and fault-tolerant manner. Throughout this lecture, we will answer several fundamental questions. What is HDFS? How does it store data? How does it ensure reliability? And how can we interact with it? Let us begin our exploration. Before we dive into the technical details, let me give you a roadmap of what we will cover today. First, we will explore the fundamentals of HDFS, what it is, why it was created, and what problems it solves in the big data landscape. Second, we will examine the HDFS architecture in detail, understanding how data is distributed across multiple machines and how the system components work together. Third, we will discuss the critical concepts of data replication and fault tolerance, mechanisms that make HDFS reliable even when hardware fails. Fourth, we will look at how to read and write files in HDFS, understanding the data flow and operations. Finally, we will get hands-on experience with HDFS commands and practice interacting with the file system. Each of these topics builds upon the previous one, so by the end you will have a complete understanding of how HDFS operates. Now, let us begin by understanding what HDFS actually is and why it was created. Imagine that you have a massive data set, perhaps terabytes of log files from a web application or sensor data from thousands of devices. A single machine cannot store or process these data efficiently. As a consequence, we need a way to distribute this data across multiple machines. This is where HDFS comes in. HDFS, the Hadoop Distributed File System, is designed specifically to store very large files by splitting them across many machines in a cluster. It has four key characteristics. First, it is distributed. Files are divided and spread across the cluster. Second, it is fault tolerant through data replication. So even if machines fail, your data remains safe. Third, it is scalable. You can add more machines as your data grows. Fourth, it is cost effective because it runs on commodity hardware rather than expensive specialized equipment. Now, to truly understand HDFS, we must ask, what kind of workloads is it designed for, and what kind of workloads should we avoid? Let us examine this through its design philosophy. HDFS excels at four specific scenarios. First, it handles very large files, ranging from gigabytes to petabytes in size. Second, it supports streaming data access, meaning applications read data sequentially from beginning to end. Third, it follows a write once, read many pattern. Data is written once and then read multiple times for analysis. Fourth, it runs on commodity hardware, keeping costs low. However, HDFS is not suitable for every use case. It struggles with low latency access, where millisecond response times are needed. It performs poorly with many small files, as each file creates metadata overhead. It does not support random writes or modifications to existing data. Finally, it is not designed for interactive queries that require immediate responses. Understanding these strengths and limitations is crucial for deciding when to use HDFS.